So we have our CIA online written exam. It will be on 18th of Jan 2022. And the syllabus would be everything up to standard errors, right? So we started this yesterday and I explained that standard error, the concept of standard error, it is nothing but the standard deviation of the sampling distribution of the estimator, right? And the sampling distribution is simply the probability of frequency distribution of the estimator, right? Which means a distribution of set of values of estimator obtained from all possible samples of the same size from a given population. So why do we have sampling distributions? Because they are used to draw inferences about the values of the population parameters on the basis of the values of the estimators calculated from one or more samples. So this part is taking us from beta 1 hat to beta 1 and beta 2 hat to beta 2. So as you asked in a few classes back, somebody asked that we have calculated the beta 1 hat and beta 2 hat, but we have not talked about beta 1 and beta 2, how to draw inferences or say something about the true population parameters beta 1 and beta 2. So the connect between the sample statistics beta 1 hat and beta 2 hat and the population parameters beta 1 and beta 2, the connect between them is the standard error, right? So let us understand what is standard error. We had a discussion on it last time also. So I'm repeating the story again. Suppose there is a population of size 100, and suppose you took a sample of size 10 from this population of 100 and you picked randomly 10 observations from the population. And then on the basis of this, let us call it sample 1. On the basis of the data contained in sample 1, you regressed y on x, and then you calculated beta 1 hat and beta 2 hat for a simple regression. So you got some value of beta 1 hat, some value of beta 2 hat. Now, if you are asked to collect another sample of size 10 from the same population of size 100, of course, the sample would be different. And therefore, the beta 1 hat and beta 2 hat, which you calculate using the OLS, would be different from sample 1. And if you repeat this process many times, you would get a lot of samples, and each time you would get a different beta 1 hat and different beta 2 hat, right? Now, if you collect all possible samples of size 10 from the population of size 100.
So just one thing, actually someone is trying to let in.
There's no one. Right? If you collect all possible samples then you would get a lot of beta 1 values, one from each sample, and a lot of beta 2 hat values, right? And there will be lots and lots of samples, therefore lots and lots of beta 1 hats and lots of beta 2 hats, right? So let us pick one of these. We can do one by one. Let us pick beta 2 hat, which is nothing but the slope of the SRF, and we are trying to say something about the slope of the PRF, because beta 2 hat is the slope of SRF and beta 2 is the slope of PRF, and we are interested in knowing the slope of PRF. What we got is a slope of SRF. So these are all the different slopes depending upon all the different samples that have been collected from the same population. Right? So let us pick one of them. Let us pick beta 2 hat, and then let us put all these beta 2 hats here on the x-axis. These are all possible beta 2 hats, right? All possible, because we have collected all possible samples, right? All the possibilities of the values that beta 2 hat can take are there on the x-axis. Of course, the values would not go very far away. They would be in some range, right? It depends upon the values of x and y in the population, right? Because this beta 2 hat is collected from samples which are taken from the same population, and there is some range of x and some range of y, and these are the two things which make this beta 2 hat. So there will be some range, and but the distribution of the values would be more dense in some range. These values are occurring more frequently, and these values are not occurring that frequently because their density is not that much, which is represented by the height of the curve. The y-axis tells us about the density of these values which are there on the x-axis. So we got a probability distribution, right? That's what we are talking about. So if you calculate the standard error, if you calculate the standard deviation of these values, beta 2 hat, all the possible beta 2 hat values, that standard deviation is known as standard error, right? Because this is the standard deviation of the sampling distribution, and this is the sampling distribution, all the different values of beta 2 hat, right? We generally understand sampling distribution or any distribution with a graph. That's why I have drawn this graph here, right? So this is the sampling distribution, all the values of beta 2 hat, and its standard deviation is the standard error of beta 2 hat. So you write it like this: standard error beta 2 hat is equal to this, whatever it is, right? So standard error is the standard deviation of the sampling distribution of the
So
estimator,
actually,
and the sampling distribution of an estimator is simply a probability or frequency distribution of the estimator, which I have drawn here. And this is nothing but a distribution of set of values of the estimator, which is beta 2 hat, obtained from all possible samples. And these are the values obtained from all possible samples, one for each sample of the same size, which is 10, from a given population of a given size, which is 100. Why do we need these sampling distributions? We need them to draw inferences about the values of the population parameters on the basis of the values of the estimator. So we will see how do we use standard error to reach from beta 1 hat to beta 1 and from beta 2 hat to beta 2. We will see this in lectures to come, right? So this is the connect. Now, okay, somebody was asking something. Please ask.
so actually somebody is trying to let in.
right?
Yes, sir.
So now the question is that how do we calculate this thing? Standard error beta 2 hat. How do we calculate it? So this is the formula.
Excuse me, sir. So,
Yeah.
so standard error will help us estimate the values of beta 1 and beta 2 hat or beta 1 and beta 2.
Beta 1 and beta 2. So these are population parameters.
And sir, so as we know that beta 1 hat and beta 2 hat are the estimators of beta 1 and beta 2.
Yeah.
So what's the relation between beta 1 hat and beta 2 hat with the standard error?
So that's what I just said, that we will see how do we do that exactly in the lectures to come. I just said this, right?
Yes, sir. Okay,
So
okay, sir.
that you will know at that point, right? So first things first, how do we calculate standard error beta 2 hat with this formula, right? And how do you calculate standard error beta 1 hat using this formula, right? Now, from where did we get these formulas? So we need to derive mathematically these two formulas, standard error beta 2 hat, standard error beta 1 hat, right? And then we can use them. So we will see how to use them. Uh, the first thing is that you should remember these formulas, these two formulas. Then we will see how to derive them. How did we get these two formulas? So we will mathematically derive them. So right now we are not deriving them. I'm trying to make you understand these two formulas, right? So see what is there in the denominator and what is there in the numerator. So what we see from here is that the denominator depends on x values. Remember that x, capital X, is what we have in the sample, whatever values are there. And small x is capital X I minus capital X bar. This is small x I, right? So that small x is used in the denominator, right? The only thing in the denominator is small x. And you can get this small x using capital X, right? So simple to get the denominator. What about the numerator? Sigma. What is this sigma? In here, standard error beta 1 hat, again, there are capital X's. So you know the difference between capital X and small x. So you can get, you already have capital X's. And in the denominator, there is small x and there is n. N is the sample size. Small x is you can get it from capital X and you have capital X. The only problematic thing is this thing in this formula and this thing in this formula. Rest is the x, capital or small, and sample size n, which you have. So to understand these two formulas, we need to understand what is this sigma. How do we get this sigma, right? Now let us talk about sigma. So all the quantities entering in the preceding equations except this sigma squared or sigma is not there. So we can get sigma hat squared. We cannot get sigma squared. We can get sigma hat squared, right? And sigma hat squared is an estimator of sigma squared, right? And what is this sigma squared? or sigma hat squared. So sigma hat squared is nothing but sum of squared errors divided by n minus 2. So when you have y and when you have x, this is what you have, the sample, right? For this sample, you can calculate beta 2 hat, beta 1 hat, y hat. What is y hat? Beta 1 hat plus beta 2 hat x plus u, u hat, right? So when you have y, when you have beta 1 hat, beta 2 hat, x, sorry, not u, uh, when you have beta 1 hat, beta 2 hat, and x, you can get y hat. And when you have y hat, you can get u hat because u hat is yi minus yi hat, right? When you get u hat, you can write it here, right? And then you square them and then you add them. You got your numerator and then divided by n minus 2, you get sigma hat squared. And sigma hat squared is an estimator of sigma squared. So you can put this sigma hat squared, of course, if you have sigma hat squared, you can square root it to calculate the sigma. So if you have sigma hat squared, you can get sigma, right? Sigma hat. So you got your sigma hat. You can put this sigma hat directly in place of this sigma, right? And sigma hat squared in place of sigma squared, wherever it is, right? Now you got your standard error. That's how you calculate it. So it is easy to calculate. We will calculate and I will show you how it is calculated. I just explained you the method, what do we get from what, and it is fairly simple to calculate this sigma, and then using sigma you can calculate standard error beta 1 hat and standard error beta 2 hat, right? Now if you have any question you can ask.
So can you please explain from the part where you told standard error of beta 1 hat? Can you tell from there once again because I didn't understand.
From where? From
So
how do we
from
get sigma?
standard error of beta 1 hat, how do we calculate that? So there the sigma also there, no? So how do we calculate that?
So standard error beta 2 hat or beta 1 hat, both of them are calculated using formulas which involve sigma. So the only problematic variable is sigma, right?
Yes, sir.
So we need to understand how to get sigma because x we already have, right?
Yes, sir.
So to get sigma, you can get residuals first. Once you got your residuals, square them, add them. You got sum of squared residuals. Put it in the numerator, divided by n minus 2, and you got your sigma hat squared. Sigma hat squared is an estimator of sigma squared. Sigma squared is a population parameter, while sigma hat squared is a sample statistic, right? So we just replace sigma squared by sigma hat squared in this formula. It is sigma squared, right? But we do not have any value for sigma squared. We can't calculate it. It's impossible. What we can do is use our sample. So we can, instead of sigma squared, we put sigma hat squared here, which we just calculated, or sigma hat here, and get our standard errors. This one and this one, both beta 1 hat and beta 2 hat, both, right?
Okay, sir. Thank you, sir.
So Let us do an exercise to calculate standard error. So I'll be doing it in Excel because Excel calculates uh, values quickly and I don't have to use calculator each time, but in the exam you have to use your calculator, right? What you have to see here is just the formulas and what is being done in the calculations. So we have a y and we have a x, and suppose y is, can you tell me the same numbers which we used before? Anyone? If you turn your pages and tell me the example that we undertook.
So when you were doing the first unit,
Yeah, when we were doing, when we were calculating beta 1 hat and beta 2 hat using OLS, we
so the
used,
example was xi it was 2,
hmm,
3, 4, 4, 2, and yi was 5, 3, 2, 3, 2.
great. So these are our x and y, and what we calculated beta 1 hat and beta 2 hat also, right? So what was beta 1 hat?
So beta 1 hat was 4.5 and beta 2 hat was minus 0.5.
Minus 0.5. Is it right?
Yes, sir.
All right. Now let us calculate the residuals because we need residuals for the standard error. How do we get the residuals? Uh, Two things to remember. Number one, first, for residuals, what we need to do is we need to subtract
Oh,
yi.
so I don't think y was 5 in the first place. It was 2. Oh, sorry, it was 5 only. It was 5 only. I'm
So
sorry.
this is how we will calculate the ui hat. This formula we will be using. For this, we need yi. We have yi, but we need yi hat also, which we don't have. So let us calculate yi hat first. So yi hat is going to be beta 1 hat plus beta 2 hat xi, right? So using this formula, let us calculate y hat. So y hat is going to be equal to beta 1 hat, which is 4.5 plus beta 2 hat, which is minus 0.5 multiplied by x, which is going to change for every value. So I've written this formula, which is nothing but beta 1 hat plus beta 2 hat times whatever x value is there for this observation. xi, right? Are you clear with this formula?
Yes, sir.
So you will, when you are using pen and paper, you will do exactly what is being done here. Here I will just press enter and Excel will give me the result. So this is 3.5. This is my first y I had. So I'll copy this formula down and it will do this for all the 5 observations for me. Right? You can see here, you can see it has done the same thing again here. 4.5 plus beta 2 hat, and then it has used this x value, this second one, right? And then here it has used the third one, 4. It has used 4 for this calculation. Beta 1 hat and beta 2 hat remains the same. So these are our yi hats, right? Now we can calculate residuals ui using this formula, yi minus yi hat. I'll write whatever yi was, which is 5, minus whatever yi hat was, which is 3.5. And I'll press enter. So you can see it will subtract y hat from y, and that's how we got our first residual. I'll copy this formula down and it will do it for all the residuals. You can see the second one, y minus y hat, and this one, y minus y hat. The corresponding calculations are done. So we got our residuals. Now remember the third formula, which says
Sir,
that
just one small thing. It may be a repetition, but I'm just confirming that yi hat is the estimator of a y value for a given x value in a sample.
exactly.
All right, sir. And sir,
So we got our UI now.
yi is the y values, random y values for in a population, like all the y values in a population.
No, in the sample, and these are actual y values. We call them actual y,
Okay, actual
right?
y values in the sample. Okay, thank
Yeah.
you, sir.
So we use this formula number 1, then we use this formula number 2. Now we are using this formula number 3. So for this we need ui hat squared. So ui hat squared. Let me write it ui hat, right? So ui hat squared is nothing but this thing squared, right? So I've just squared it and copied the formula down. So these are the squares of these numbers, right? Now we need the sum of these numbers. So I'll add them. Sum of these numbers. This is 5, right? And now I can calculate my sigma squared. Sorry, this is sigma squared, not sigma. So sigma squared equals n summation ui hat squared is 5, right? Divided by n minus 2. So what is n here? Sample size. So sample size is 5 because there are 5 observations on y and x. And n minus 2 means 5 minus 2, which is 3. So sigma squared is 1.66667. And we can calculate sigma also using the square root of the above number equals square root, sqrt means square root of this number 1.66667. I press enter, we got the sigma. So we got our sigma and sigma squared, which we needed to calculate standard error. Now we will calculate the standard error per se. Formula number 4, standard error beta 2 hat equals so just see the formula. It says that sigma divided by summation xi squared, right? Sigma divided by square root of summation xi squared. let me write the formula here. Sigma divided by square root of summation xi squared, right? Now I'll use this formula. So what do you need? You need the denominator because numerator you already have sigma xi squared. So first of all, let us calculate small x. Small x is going to be, okay, first of all, let us calculate mean of x. This is going to be sum of x divided by 5, right? Or you can simply write the mean function in Excel, average of these x values, which is 3. So we got the mean of x now. Now I can use the formula each x number minus the mean, or let me just write 3 here, 3, and because I need their squares, right? So I'll square it here itself, right? So this is what I wanted. And now I'll copy the formula down. So these are the x squared, and I'll sum it now. So if we add all these numbers, we got sigma x squared to be 4, and then you can take the square root of these this 4, this sum, to put it in the denominator of the standard error. Now we are all set to calculate standard error beta 2 hat, right? So what is the numerator? Sigma, which is this, divided by square root of this sum, right? Press enter. That's standard error beta 2 hat, and standard error beta 1 hat can also be calculated in the same way as we did for standard error beta 2 hat, right? So to check it, maybe I've made a mistake in some calculations. It is very much possible here and there. So to check it, I'll run a regression here, because Excel will tell me whether my answer is right or wrong like this. So I'll go for regression, select the Y range, select the X range, labels are included, output I want to put somewhere here or here, press OK, and you can see this value of, this is beta 2 hat, this is beta 1 hat, this is beta 2 hat, this is standard error beta 1 hat, and this is standard error beta 2 hat, 0.64549, and what I have calculated is 0.64549 here. So I have Excel, what regression output gives us is this value, and I can check it by calculating by hand. So this is what you are supposed to do using pen and paper by hand, using these formulas, right? Now this one is a homework for you. You have to calculate standard error beta 1 hat, which is 2.0207 for this data, using formulas. How would you do that? You will go through the whole process as I went, but in the end, instead of standard error beta 2 hat, instead of this formula, you will use the formula of standard error beta 1 hat, which involves the same variables. It involves sigma It involves capital Xi, it involves small xi. That's it. And it involves n, which is sample size, right? So you have all these things and you can simply calculate them using the formulas mechanically and you will get this value. So you'll do it today as a homework. You can see the formula here for standard error beta 1 hat here, this one. So you need a capital X. You already have capital Xi. So you can square them, sum them. That's the numerator. Sample size n is 5. Summation xi squared. We just calculated. These are small x's. Small x's means deviation from the mean. Square them, sum them, multiply by sigma. We already calculated sigma, so you don't have to calculate sigma also, right? Because it is already being calculated here in this example. So if you want, you can
So could
okay.
you once again just define what do you mean by sigma and standard error?
Okay. Uh, Standard error is the standard deviation of the sampling distribution of the estimator, right? We calculate standard error using a process, a set of formulas. Now we can never have all these beta 2 hat values because we can never have so many samples and we can never calculate. I mean, once because we can never have so many samples, all the possible samples of size n from a given population. So we can never get this distribution of beta 2 hat, right? Now, without having these beta 2 hat values or beta 1 hat values for all the samples, we can still calculate standard error using this formula, right? And this formula. So the question you might be thinking, how can this be possible that this formula calculates the standard error, which is nothing but the standard deviation of the sampling distribution, and we don't have sampling distribution? Without having that sampling distribution, how can we calculate standard deviation of all the possible beta 2 hats obtained from all possible samples of size n? You might be thinking, but once we derive it mathematically, and once we move forward and understand a little bit better about these things, you will understand this also. Right now, what your goal is to learn how to use these formulas to calculate standard error. That's what I explained you in this class today, how to calculate standard error beta 2 hat. So knowing the definition of standard error is important. As I just explained you, what is standard error? How do we calculate it using formula is what I just explained you. These two things you should focus on, and uh, you may find these two to be unrelated. You might be thinking that I explained what is standard error was something else, that there is this sampling distribution of all the possible beta 2 hats, and then its standard deviation is standard error, but we didn't go that way because we never got all the possible samples and all the possible beta 2 hats, but still we managed to calculate standard error without having to do that process which was explained in the definition. Yes, there is a connect here. We have to derive it mathematically. At that point you will be understanding it better. So just don't connect these two things right now. Take my word, just calculate standard error beta 2 hat using the formula and understand how I define this and how it is written here. Right? I just read the definition from here and
So
do it for
basically, we
beta 1
should
hat.
not
So,
focus on the concept behind the formula right now.
yeah, the concept is there. I mean, this is the concept, right? The only confusing thing is that if this is the concept, so we should have got obtained all the samples and then we should have calculated the standard deviation. The point is we cannot do it, right? This is something which is impossible. So when something which is impossible, which can't be done, we have to get our way You have to find another route to reach the destination. And this formula is another route. It doesn't mean that the concept changes. Concept is the same. The definition of standard error is the same. But how to get it, there is some way around which is explained in the formula. The formula gives us the way around, right?
All right, so got it. And so do we have derivations of these formulas in our syllabus?
Yes, yes. We have all the derivation and we will do that.
All right, sir. Also, sir, could you please upload this recording as well as the PPTs in our classroom because we have the exam on 18th, so we need to prepare.
Okay, so I'll do that. So for exam, you should practice calculating the betas, calculating the standard errors, two things of both beta 1 hat and beta 2 hat, and then read all the theory which is there up to standard errors. Of course, I will be expanding on it in the next class, which is on Monday, and that would also help you in understanding this concept better. So should I upload this Excel also, this sheet?
Yes, sir, that would be helpful.
All right, so I'll upload this sheet also, and I'll upload today's recording also. So just go through the recording and see the sheet and the formulas and practice.
All right, sir. Also, sir, the previous PPT is also not there, so if you could upload that even.
Okay, PPTs also I'll upload.
All right, sir. Thank you so much.
All right, so